hotspot, don't worry. And we are back into the recording mode, so you don't have to worry about. I'm sure there will be hassle-free. Okay. Now I want to check with you. Do you have any question at this point in time in terms of looking at the example, in terms of looking at the classification? I was talking about the dependent variable. Any question here? Is it going smooth? I see that people are giving a thumbs up over there. Yeah, thumbs up matters a lot. You writing in the chat box also matters a lot. Come on, Ashwani, Kashyap, Amit. Yeah, thank you. Kaif, Gaurav Sinha. I see the good number of hands. Yes, 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 yes. Very good, very good. Keep that momentum under control. And now nobody can stop us because the laptop is fully charged. I'm having my hotspot, which is an amazing one, which I use for all my online meetings, the classes. Everything is going smooth. And you take care of your devices. Right. I was just saying that in the case of a bank, if a bank wants to see the list of customers and predict whether that customer is likely to be default or not, when you say your target is yes or no is a categorical outcome. And that's where when you have, I'll come to that, Akansha. I'm just going in a reverse engineering. I haven't gone to the regression yet. Yeah, I'll come to that point. Now, in this case, we understood that when we have a category, something like say yes or no, section A, B, if I want to classify the data, then I use a technique called as a classification technique, which is so popular in the industry, right? And now moving on to the next item from categorical outcome to the continuous values. Now, the moment when you see the values here, it is not a alphabetical. It is not a alpha. It is not alphabetical. It means that it is a number. It is a number. When I say it is a number, it is a continuous number. It is a continuous number. It is not something like say the whole number. It is not something like say 5, 10, 6, 15 like that. It is not necessarily like that. When you see the continuous values here, what is the example I can bring in? I can bring in the example of a Flipkart and the Amazon in terms of the e-commerce industry. Now, I'm interested in terms of predicting the sales. What could be the sales at a customer level? Now, sales, we know that sales is a target here. Sales is a target variable. Target variable is also called as dependent variable. I'm sure by now you already know that it is also called as the dependent variable. Now, we want to predict this sales. In order to predict the sales, we need to understand what is the sales variable is all about. It is a continuous variable. It is a continuous variable. Why? Because sales here I'm talking about is measured in terms of dollar, maybe the amount is measured in terms of dollar or INR rupiah. And when you see the amount, it goes with a continuous number, and you don't have something called as rounding off number. You don't have something called as, again, the perfect number. Not a perfect number, not a whole number, but it is a continuous number. Now, I have a question here which says, what is the difference between classification and logistic regression? Both seem to separate data into yes or no categories. Yes, but there is a slight change. Slight change. Gunjan, don't worry about that because we are still in the first type of learning. And in the first type of learning, I am representing now classification and the regression. Someone is on a mute. I think you should be on a mute. Let me fix that guy. Anubhav, come on. Yes. Akansha, you're clear with the continuous variable now? Continuous values? Akansha? Hello, Akansha. I'm just waiting for your response. You're okay in terms of understanding the difference between categorical and continuous values?
Yes, sir. Yes, sir.
Perfect, perfect. Thank you. So here, in the case of a continuous values, you can also take the example of, since I have a finance guys here, it is very easy. Your stock market data, stock prices data, it will be having say 100.55, and then some stock prices you will be seeing 99.85, which means that there is a continuous number with the decimals also, and it is going on. There is nothing called as a rounding off number or a perfect number or a whole number. And that is the another example other than the sales dependent variable. Now, by the way, what is regression? In the case of a regression, we need to understand that there are two things. One is the dependent variable, which I was talking about, and the another one is the independent variable. Now, in the case of the supervised learning, our independent variables are very clear, very specific. Why? Because we saw the example predicting the loan customer being a default, having the data of income, age, and then credit history. When we have these three, consider these three as the independent variable, and using these independent variables, you can set the dependent variable as loan status default, yes or no. So that is possible. Sales can be dependent on various factors like, say, the cost, the advertisement cost, the pricing of a product. Like that, you will be having so many points, so many variables. Now, let's go back and then see what is the concept of supervised learning. This model, what we are talking about, the supervised model, supervised learning is a model trained on a labeled data, which means that input output pairs. Very simple. Very simple. Let's stick to the one example to understand more clearly. You have a default status, loan default status. On the other hand, you have income, age, and then credit history. Input, output, and we have a label data, specific data, and then we are proceeding. Now, what happens in this model? What happens in this learning? The system learns the relationship between input variables, features, and the output, that is the target. We wanted to know the default yes or no, default as yes or no. We want this as the output. To get this output, we will have to get into the age, income, credit history in my example, which I already talked about. So what is that the machine is trying to do? System is trying to do. System is trying to build a relationship between the target variable and the independent variables. Features is the another word which is for the variable. We already discussed this in the class. Now, once trained, the model can predict outcomes for new or unseen data. This is something I'm sure very easy to read, but very difficult to understand. Now, when I say, take a close look on this, this is really important now. When I say you come up with a model, how is that model will be helping the organizations to predict the outcomes for new or unseen data? What does it mean? Let's say with a bank, you have taken the last 10 years data. Last 10 years data. Data of what? Of the customers. What kind of customers? The loan customers. Loan customers. And you have age, income, credit history as the other three variable data. Now, when you are building a model, when you want to come up with a model, a prototype, which will help to identify the default in the future with a unseen data or a new data, what is it you have to do with the historical data? With the historical data, I bifurcate here 70% and 30%. Let's say, in simple words, I'll go with 7 years and then 3 years. So what I'll do here, this is called as splitting the data. Now, when I say split the data, I'm splitting the data into two types. This is really amazing. A great moment here at this moment with the Shulini students for me, because now I'm talking about the core aspects of the machine learning. I'm enjoying here. Come on, enjoy this. Now, when I say 70%, I'm splitting this. I'm splitting 30%. What is this? I'm using this 70% or a 7 years data, which is called as training data, which is also called as train data. Train data. This is what the internet says. Your ChatGPT says. Train data. I am taking the last 10 years data. In that, 70% of the data I would like to take as a train data, meaning I want to build a model. I want to build a model on this training data. And what I will be doing, I will be testing that model. I will be testing that model on the 30% of the data. And this 30% of data is now called as test data. Test data. So here for a prediction, I'm not going to the new data at all. I'm not going to the new data at all. First of all, I came up with a model and I want to check whether the model is working superb or not. Now, how do I check the model efficacy? How do I check the model efficiency? I check the model efficiency in simple words, very simple words. When I have this range of data, 70% of the data I take for model building. And once the model is ready, I test that model on the 30% of the data. When I have a 30% of the data, that is called as a test data. So you will be getting trained by me. You will be getting trained by me to understand and then to do train data split and test data split using only Python, please. I'll be using Python to help you guys to understand train data, test data, splitting data set under the supervised, unsupervised reinforcement. In simple words, in the machine learning. Any quick question here before I move to the next type of learning? This is the only complexity level where I just touched, but I'm not getting in detail because I have still so much of time to be with you. I should control my emotion. I should control my, say, enthusiasm, saying that, okay, I am into the machine learning core now. Wait, I'm relaxing. Let me check with you. If you have any question here at this point in time, please do ask me. You can write your question in the chat box. In the meantime, what I'll do, I'll start comparing this supervised learning with the unsupervised learning. Let's see the chat here, what it says. Sir, again, the train data and test data. Yes, Akansha. Now, I was just telling that, let's say I take last 10 years historical data. And if I do the analysis, if I do the model on the entire 10 years data, then you will come up with the model, which you and me did throughout our education. But now we are talking about the machine learning. Let's say you have 10 years of data. That 10 years of data is split into two. Now, when I say it is split into two, please keep in mind we are splitting it into two, meaning we want to first of all build a model. We want to build a model. For that, we need a data. Okay. Once the model is built, we want to test the model. We want to test model to check whether model is working fine or not. To check the model on something, we need a data. So what we do from the historical data, let's say you have got 100 years data, you will be classifying it into two types. One is 70% of data and 30% of data. Someone might say, why 70-30? Can I go with the 80-20? You can. You can. 70-30 is widely used by some industries. 80-20 is widely used by some industries. I use 80-20 for my research. I'm into the cryptocurrencies, Bitcoin, and the US economy, the Standard and Poor 500. I talk about that. I go with the 80-20. I have a strong reason for that. In the same way, now we are just talking about, since it is a starting stage here for you, 70-30. Now, for 70 years of data, using 70 years of data, you are building a model and you're checking your model on the test data with that 30 years of data where you already have, which is in the past. So we want to check what is the model doing. On what you will be checking? You will be checking on the test data. Once it is ready, once you say that, okay, model is working fine, that model goes and then it can predict outcomes for new or unseen data. Before you release your model to unseen data, you will have to test your own model with the past data. And when I say past data, the past data is divided into two types. One is the training data set and the another one is the test data set. Training data set is used to build the models. Test data set is used to test the model which is built using the training data set. Akansha. Sir, if I test the model, what percentage of accuracy can be considered acceptable? This is a very simple question for me, but this is highly complicated in the industry. Every individual who is called as the consultant, they come up with their efficiency, their skill in terms of the accuracies. And that's where the hackathon competitions are so popular in the world, right? Gunjan, this is the challenge now. I can easily say that the accuracy percentage, if you say 100%, then are we replacing the Lord Brahma? I don't know whether we will be replacing Brahma or not, but one thing is for sure, to the extent of 70%, 75%, 80, 81, 82, 83, like that, until 90, 90, until 95%, maybe you can reach with the models, and then you can say, my model is working accurate to the extent of 90% or 95% or say 91.76%, but definitely not 100%. And what is acceptable? The highest percentage of accuracy is acceptable. Now, who is coming up with the accuracy percentages? The consultants will be coming with the accuracy percentages. And that's why if you see the competitions online are online and they say open for everyone. Any person who comes with the highest accuracy will be the winner. That's it. That's how the game is all about, the machine learning. Gunjan. That's my answer to you and to your question. Akansha, thanks for acknowledging. Yes, perfect. So, after understanding something about the supervised, let's try to differentiate now with the unsupervised learning. Now, again, I would like to go first with the example here. I don't want to get into the meaning of it. To know the meaning, you will do that. That's your business, not my business. My business is to help you to understand in terms of applying it, right? Okay. I'm going with the second example here for the day, for the second type of learning, which is unsupervised learning. If you see here, I'm saying grouping Flipkart customers into categories like discount seekers, regular buyers, premium shoppers without predefined labels. By the way, we do not have a label at all for a customer. Take a close look in the case of a bank loan. When you took the past data will say whether the customer was default or not default. It should say, that is why we are referring to the banking past data. And when you talk about the Amazon or a Myntra or a Flipkart here, the e-commerce industry, the companies, they have n number of customers. And now they want to categorize their customers into three buckets. One, the discount seekers, someone who always filter buy and then check for discount 25% more, 50% more, 75%. Someone is looking by filtering the discount. That is the key to understand, okay, who the customer is looking for the default discount seekers. And regular buyers, they don't look at the discount at all, but on a regular basis, they'll be having some shopping over the online. Now, with my Amazon, I'm under the category of a regular buyer. I can also say I'm a premium shopper. Why? Because I'm having a Amazon Prime, and then every now and then my when I'm here in Shulini, when I'm here in Himachal Pradesh, my Amazon account is basically used for the grocery, which comes from Karnataka. Yes. Now, this industry is looking for classifying or categorizing customer into three buckets. But the label was not existing for the customer. We are giving a label. Now, where do we see this kind of challenge? If you see the retail, big bazaar, Reliance trend, the customer segmentation is something which is so popular. Budget versus premium shoppers. In the case of e-commerce, if you see market basket analysis, which is really so powerful. If I get a chance, what I will be doing is I would like to conduct a workshop in the coming days for you. This is my plan, in fact. And the workshop is focusing only on MBA. Now, when I say MBA, what is that? Not your MBA. I am talking about the using machine learning, market basket analysis, which talks about items often bought together. If you remember, I was talking about as an example, if a customer buy eggs, what is the next likelihood of picking the product? Maybe milk, next maybe the bread, which you said. But other than these things, can we find something, a relationship within the universe of so many products? It is possible, and that is called as a MBA, market basket analysis. And if you talk about the Geo Airtel, the telecom industry, what is that they are doing? They are trying to identify usage patterns for targeted offers, usage patterns. Now, if you see here, market segmentation, market basket analysis, usage pattern, these things are something which not already available for us. This is what the target is. And to do this, we will have to understand what is exactly the idea of unsupervised learning is. So, what are the techniques you will be using? You will be using clustering technique, association technique, dimensionality reduction, that is a PCA. PCA was introduced by me as a part of syllabus, but then it is now taken back after seeing that it is not offered. This course is not offered only for the core business analytics. Now, there are three important techniques. This should be your target. You can learn like a Ekalavya of your own. You don't have to wait for your teachers, you don't have to wait for your classes, but you know the roadmap and then you can start studying. Clustering is something like, say, the group similar data points. Like I just gave an example of making the three categories. Yeah, three categories. Go back to this and let's see the example. Regular buyers, discount seekers, premium shoppers are the three different segmentation which we would like to do, and we use the clustering technique for that on the same data. Association, find the relationships between items, association problem. Now, when I say association, the answer is MBA, market basket analysis. Let me help you with that by writing here market basket analysis. If you have a task of coming up with identifying the relationship between one item to the other item, then you will have to work on the MBA. And for the similar data points clustering, it's a customer segmentation. Customer segmentation. So this is about the clustering technique. Now let's go and see what is this. It says that now unsupervised learning is all about a model is trained on the unlabeled data. In the universe of data, you don't know what is your target. When you don't know your target, you are trying to label, you're trying to identify what is that you would like to do. If you would like to do a customer segmentation, yes, of course, you're working without knowing the segmentation of a customer. You're trying to create a segmentation. For that, you will be going to the clustering. Now you have the universe of items in the retail industry, online shopping or e-commerce. See the relationship between one product to the another product or one item to the another item. And this is possible with the help of association. For now, I would like to keep I would like to keep this under parking mode. I'm parking this. However, we will revisit soon on this particular item. I would like to park this, but please keep in mind there is a technique called as PCA, principal component analysis, which is widely used in order to reduce features while retaining the information. What does it mean? For that, we will be revisiting sometime later in our course, but not now. So this is called as unsupervised learning. Any quick question here on unsupervised learning? I'm tracking your chat here. Sir, how we will test the model in case of unsupervised modeling project? Yes, very good. Now, again, in case of unsupervised learning, we go with the trained data set and the test data set. Now, here, if you see in the case of the customer's data set, let's say this is my entire data set. This is my entire data set. In this, what I'll do, I'll just apply normal distribution of data into two categories, and then we come up with the trained data and the test data, and we apply the same techniques what we are aware of in terms of building the model and then checking the accuracy of the model. Because from 70% of the customers, you will be knowing that yes, we have a model, and with that model, you can compare the other model by building another model with the 30%. And if you will be doing this in the class as a part of our learning, and you will be seeing that how trained data set and test data set will be helping us. My voice is lagging, really, but I don't see any challenges here. My video streaming is so live. let me repeat this question. How we will test the model in case of unsupervised learning? It's very simple, Gunjan. We will be applying the same technique of the trained data set and the test data set. We build the models at a different data sets, and then we compare the models with the accuracy, and then we say which model is working best. So therefore, we come up with a lot of model creations, model developments when we talk about the trained data, the test data. And it is possible we will be doing just like in the case of supervised learning, we will be doing in the case of unsupervised learning also. That's my response for now. But when we get into the action mode, you will be seeing that how they are different. For now, it's okay. Perfect. I saw your confirmation over there. Now, in the interest of time, and then to touch the last technique, which is called as the reinforcement learning. This we will not be doing at all. Reinforcement learning. Let me help you. This is really amazing. We already looked into the example, which is called as a Swiggy. Swiggy, what is that the Swiggy will be doing? Let's see the example. A reinforcement learning agent for Swiggy learns which delivery routes minimize delays and maximize customer satisfaction. From your own learning, you're trying to learn and then improvise. And this is same in the case of Indian business applications. If you see here, in case of food delivery, Zomato, Swiggy, they are doing it, they are applying it. Now I see that there might be a lag in terms of my audio, so I'll just stop my video for a moment and you should be able to see this. In the case of a Zomato, Swiggy, optimizing delivery routes to minimize time and maximize customer satisfaction is possible. In the case of a stock trading, NSE, BSE algorithms, learning strategies for profit, trading strategies for profit. If you talk about the smart cities, like say Bengaluru, active traffic control to reduce congestion. These are some of the popular application where you can see the reinforcement learning is applied. Now, in order to do these things, we need a technique like Q learning and a deep reinforcement learning. Are we training you guys on the Q learning and a deep reinforcement learning? No, we are not training you guys. Maybe we will have to look for some workshops for the interested students. Now, if you remember the ChatGPT, if you remember the Gemini, if you remember the DeepSeek, what is they do? They do learning from their own learning. They are reinforcing their learning. And what this model is called as? This model is nothing but they try to learn through trial and error by interacting with an environment. I was just talking about the AI, like say ChatGPT, Gemini, what is that they do? On the basis of a trial and error, on the basis of the learning, whatever they have, they try to relearn from their own learning. Therefore, it receives rewards, that is a positive feedback, or penalties, which is a negative feedback for its action. And the goal is very clear, maximize cumulative reward over time. Simple words. Remember this example. In the case of the Swiggy, they learn their own learning. And it's a trial and error. They don't have a definitive answer at all. They are going deep, deep, deep. And going deep is called as the deep learning. And that deep learning is called as deep reinforcement learning. And these are the three types of learning which you should be aware of. And I'm really thankful for the online sessions, whatever we I'll be sharing this document with you guys and take a close look on these things. It will help you to understand whatever the discussion we made. And I'll give some task. Stay tuned.